Alright, so let's see if we can't get this assertion junk done. Okay, so first of all, we need to take some snapshots here of some information. So the current key is going to be context.key. What else are we going to need? We're going to need to know what the stack size is. Equals context.stack size, and the offset is going to equal context.offset. Alright, so this is info I need to hold on to. Let's see what happens when we evaluate the token. So the result of actually trying to match here, match item dot match, all in the context, will get stuffed in result. And I'm going to say if we are not a positive match, then result is going to equal not result, right? So if it's not a positive match, then if this does match, we will fail, and vice versa. Okay, so some stuff we definitely are going to do. Now that we've completed matching, no matter whether we succeeded or failed, I don't actually care. This is going to equal this offset here. So I'm going to restore the offset, restore the context offset, and I'm going to restore the stack. So context.restore stack back to stack size. Okay. And this restores, well, I'll say it like this. So this removes backtracking information from the stack, right? So if we've succeeded, and by succeeded we just mean if the ultimate result of this assertion is positive, then we are going to say context dot push the, what do I want to put? Oh, the current key, right? So if it worked out, I want to write down in my backtracking info where we were at, the largest key that had been used so far. If, however, I failed, then I will also, well, not also, I will do the following. So I will restore capture stacks of, where was I? Current key. Sorry. Duh. That's what I want to do. And then I'm going to return the result. Okay. Alright, so let's think about this for a second. Suppose I have a positive assertion, and it's going to succeed. So we come into the match, we take a snapshot of how many captures we've done, what the backtracking info is like, and where we started. We attempt to match it, and we determine if we are ultimately successful or not. No matter what happens, we're going to restore this stuff back. So it's an assertion, so we push the offset back to where it was when we started. There's going to be no backtracking, period. This is an assertion, so we just dump that info. If it was successful, we write down what the current key was so that when we get backtracked into, we can restore it. Otherwise, we throw away anything that's been captured. Now keep in mind, this could be completely successful, right? This could be totally successful, but I could have a negative look ahead, for example, or a negative assertion, and there's going to be all kinds of stuff captured in here. The backtracking junk we've already thrown away, and in that case, I want to throw the capture info away, and then ultimately just return whether or not we succeeded. So, what does that mean for being backtracked into? Well, effectively, the only thing we got to do is restore the capture stacks back to where they were. So we will say int max key equals context dot pop, right? So we'll pop that guy right back off, and then we will restore capture stacks to max key, and then return false. Okay, there's no alternative for an assertion, but this restores the state. Now this is interesting because notice that we are never calling match item match next, right? I'm not, when I get backtracked into, by the way, I've already thrown away everything it could have possibly saved. And if I get backtracked into, I really throw everything away in case he captured anything and we fail, right? Which will just mean that whatever's calling me is going to skip over me and keep backtracking backwards into the rest of the regular expression, whatever that happens to be. So let's see if we can test something here. Public static void assertion test 1. So I'll actually call this positive assert test 1. And we will need all of our usual stuff. I keep hitting tab expecting it to know what I'm trying to say here. Oh my goodness. New context. I can't think of anything in particular, and I'll probably change this later. We will need the boilerplate stuff. It goes new character, and in case you're curious why I'm not copy pasting, sometimes I copy paste and I forget, and then stuff goes wrong, and so I like to type it out. So what should we do for our assertion? Well, let me write down my regular expression first. So I'm going to do the following. I want to do a greedy match followed by a positive assertion that I see 2 A's. But to make the testing a little better, I'm actually going to roll them up in a capture group, and that will help me look at the backtracking junk and make sure that works. Okay, so this is what I'm going to create, so let me just make that happen. So var list of 2 A's equals new list of new iMatch array chart A twice. What am I going to need? Var cap, I'll call it cap1 equals a new group, and this will be of list of 2 A's, and this is capture group 1, and that's going to be this guy. I'm going to need an assertion, var assert equals new assert of my capture group, right? And yes, it is in fact a positive assertion. And I'm going to need greedy, so var greedy equals new greedy, and this is going to be char A, and it's going to be 1 or more times, right? Like so. And then finally, we're going to have our regular expression, which is a list of the greedy token followed by the assertion. So var token is a new list of a new iMatch array, which contains first the greedy token and then my assertion. Okay, so I think that's what we want. Now, let's test it using this token on this context. And then let's call it. Oops. And we failed. Okay, let's think about what happened here. Well, I guess we can go back. First thing that happened is we tried to match, and we matched the first 2 characters, and then we asserted that if we look ahead, we would find the 2 characters AA, and that is in fact true here. You can see that the match, what must have happened internally is that the match consumed greedily and then couldn't match the assertion until we backtracked to this point. So we stored the 1 optional 1 here, and the 0 there is something else. Oh, it's the key. It's the largest key that we've used. And then after that we crashed. So I guess we'll go back over here. And group ID is 0. Unsurprising. Restore capture stacks. Where's my call stack? So we're matching next back to 0. And then I go to restore capture stacks. and for each group in the keys, while I peek and the key for that guy is greater than 0. Oh, this guy doesn't even really exist. If I peek at the group, right, then that's, I haven't captured anything yet, so that's the deal there. So, you can be smarter about this. So while, group has value, I guess I could do that, right? Capture stack contains key, group ID, blah, blah, blah. Okay, so we'll do while group has value for my group ID and that. Then we will restore capture stacks. And I guess I should correct that. Am I going to need to do the same thing for restore stack? I don't think so. All right, let's try it again. Hey! All right, cool. So now we issued a match next, and we unrolled whatever was in group 1. We threw that away. And we backtracked, and we've now matched the 1 minimum and none optionally of our A, this guy right here, our greedy A token. And then I guess I'm a little surprised that the key that we captured here is 2. Let me think about that. So I had to pause it there and actually think about it. And this guy is 2 because the way we write exec tests is we wrap the entire expression in a regex, and a regex is really just a subclass of group where we automatically set the group ID to 0. So because the entire regular expression matched, this guy is in fact a capture group, and so its key was 1, but that never gets put anywhere, right? I don't keep track of that. So the next available key then was 2, and that explains why that's 2. So, okay, so let's do one other thing. So now that that works the way we think it should, notice that I need to be able to look ahead and see 2 A's, and so these are all the ways that that can happen. Another thing we could do would be, instead of this, we could do 0 to many, right, which is star. Is that right? I think that's right. It's been so long since I've actually written one that isn't ridiculous that I forgot. So let's make the greedy 0 to many, and we can see that these are all the different ways that we can do that while still having 2 consecutive A's after us. In every case, this is captured, right? So now I will copy paste this and make it a negative assertion. That will be the only change, right? Negative assert test 1, and I will make my assertion false here. And this should be all of the cases, all the ways that we can match that, besides the ones that we just saw. So I can consume all the way to the end, getting all 4 optionally, and capturing that with my, well, I guess this is a little funnier. My look ahead is negative, so I don't actually store any of that capture info, but that's fine. So this works out, right? At this point, I've consumed all 4, and I do not look ahead and see 2 A's. I can backtrack once, and I can get here. Notice now the regular expression. There's 0 and 1. Those are our keys. I can do 3 optionally, and I can look ahead and not see 2 A's. But after that, I backtrack to here, and after that, there are 2 A's, and then we're out of luck. Everything is restored, and the stack is back. All right. So positive and negative assertions. In this case, we're just doing a plain vanilla look ahead, including capture groups, seem to work. So this assertion, this idea of, there's some extra work that you have to do to get around the fact that we're not actually calling that match next, and we had better be smart enough to restore everything back correctly. Otherwise, the state of the context will be broken, and who knows what's going to happen. It's not going to work out. So, okay, I guess on to the next token.